All right, so today I'm gonna take apart my power inverter and pull it all apart and measure out all my cables and show you all the components that I use to construct it and install my power inverter. Here you go. So this is the trunk area of my Model Y. Here's the surge protector that pops out from the sub trunk. If you pull this out, look underneath, there's my power inverter. It's a 1000 watt from Eastwood. 1000 watts. Do not use a 2000 watt. A 2000 watt is too much power for the Tesla to handle. It's not going to be able to power a 2000 watt because I tried it. So, but anyways, this 1000 watt is perfect. So far, I haven't had any issues with it. So anyways, this is what it looks like. It's underneath here. I have 2 power cables going towards the penthouse of the car. Here's the positive 12 volts. Here's the negative. If you follow these cables, they're 2 gauge. All right, these are 2 gauge. It goes over towards the left side of the vehicle on the driver's side, in the corner right there. I don't know if you can see that in the corner underneath, towards the left side of the vehicle. So here you go. Here are the 2 cords that come towards the passenger row in the back. And basically it comes out through here over by the seat belt area. I think hopefully you could see that. And then it comes around, and then it gets shoved underneath right here in this corner on the left corner of the back row seat right here, and then it goes towards the 12 volt DC to DC converter over there on that side. So anyways, you need to remove this. To remove the seats of your back seat, you just have to pull up 1, pull up 2 from there to release it. Once you release it, then you can just pull it straight out. Once you pull it straight out, it exposes your penthouse area. All right, you're gonna have to unhook the power cord here, one of these wire harnesses. Unhook it there, and it's actually hooked. There's 2 hooks here, so you'll have to unhook it at both sides, and then you can bring the seat down there. So anyways, this is what it looks like if you follow my cord from the back sub trunk area. It comes around here, then it makes a U-turn, and it goes underneath here into the penthouse area, where I added an Anderson plug or Anderson connector right here. So from this Anderson connector, I can disconnect it right here easily. So they pull apart, boom, just like that. It has a cap. I can put the cap on this and cap that off. And then this, I could cap this off. So this has a couple of contacts right here, all rated for 2 gauge. Boom. So you can cap that. You can remove this just like that. You can take this, bring it to the back seat. Just like that. Then you can remove this, just like that. And then you can take this to the back. And then all you have to do is you can coil this up. Coil this up just like this, and then coil it up to the power inverter, and you can put it away. If you want to take it away and put it inside your house, you can do that, or use it for a different car. So here you go. I want to show you my power cord. What I did was this power cord goes over to your 2 contacts, which is over there in that corner. We're going to take that apart, and I can show you how I hooked everything up. I do have a zip tie that I zip tied one of the cords to right here to this metal bar. That way, that's just in case somebody pulls on. If somebody pulls on this, it's not going to pull. It's not going to put any strain on the connectors over there where it's hooked up to the 2 studs that goes over to the DC to DC converter. So, but anyways, this is what it looks like underneath. So it's not going anywhere because it's tied by a zip tie right there. All right. Now this is what I'm talking about. You can take this and you can coil this up. Just like this, so it's nice and neat. Then you can take this and take it away. Put it into your other car. If you want to hook this up to your other car, you can. Or you can leave it inside the house. It's up to you. So that's what it looks like over here. It's hooked up to the positive side and the negative side of my power inverter. That's pretty much it. So now let's go over to the penthouse and take that apart. That way you can see what I did over there. Right, so now I'm going to take you over to my DC to DC converter and disconnect the connection over there so you can see how I put everything together. So anyways, first, to get over to the DC to DC converter, you need to remove this rubber seal. You need to remove this plastic panel. That way you can expose that area right there and you'll have enough room to work with. All right, so that's pretty easy. You just have to pull up straight with this rubber seal. Pull up straight and then get that out of the way. Once you get that out of the way, then you can pull up straight on this plastic panel. But there's a few clips here that you need to pull up and remove. So once you pull it up like that, it'll start to come off. Pull up, pull up. There's a clip right here. I don't know if you can see that you need to remove. Right there. Yeah. And then once you pull it out, let's slide this out. So here you go. There's one clip over here on the far left side that goes into that slot. There is a couple clips down here that go into those 2 spots right there. And then looks like there is this right here, which has to line up with that hole down there. And then you got these guys right here that need to line up with this hole in that slot right there. So basically that's how that fits right inside there. So you just got to pull straight up and out, and then later on slide this out this way to the right, and then you should be able to pull this out. Okay. Then there's a support right underneath this that supports the weight of anybody kind of stepping right there. So you need to pull this one straight out. Pay attention to how this fits. There is a rib right here that you have to line up with a slot on the this plastic support right here. See? I don't know if you can see that, but see this rib? And then you have this slot right here on this plastic support. That needs to line up just like that when you push it back in place. So pay attention to how this looks before you pull it out. That way you know how to put it back in. So basically, this is that slot that I was telling you about. That's the slot that needs to line up with this rib right here, this metal rib right there. Pull this one straight up like that, and then take that out of the way. All right, so this exposes our DC to DC converter right here. So if you pull this up out of the way, you can see that here's your positive that is hooked up to your positive 12 volts of your DC to DC converter. And then here is your negative, or your ground, that is hooked up to the negative stud here, or bolt, on the other side right here. And there's a nice plastic barrier in between to keep the two contacts away from each other. So be very careful when you remove this nut. Be very careful when you remove this nut so that you can attach your 2-gauge cable over to that. You don't want to short this out when you're removing it. So make sure you insulate your socket wrench before you remove that, just in case when you're removing it, you might end up hitting a piece of metal here. So, but anyways, that's what it looks like underneath here. Yeah, so here's my my inline fuse that I added. It's a 100 amp inline fuse. And yeah, let's take it apart. Yeah, I forgot what. It's a 13 short die. So socket wrench, and you could wrap this with some electrical tape or some sort of tape that'll insulate it, since it's metal. You don't want this touching anything, but that's what I suggest for you. But I'm just gonna try and be careful here before I do this. All right. Make sure no metal is gonna touch anything. Right there. All right, once it's loose, don't touch any metal. Be very, very careful. Yeah, this is a different rubber cover that I purchased from Amazon to cover up my positive side right there, to make it nice and insulated from the rest of this vehicle, just in case you don't want anything touching that. So anyways, let's take this apart so I can show you. Alright, so that's it. So we're gonna loosen this up. All right, that's it. Then we can pull this contact out. This is the scary part. Do not touch any other pieces of metal while you're touching that. Okay. Now you can put this back. Just like that. Tighten this down. Just like that. And then stay away from it. Take this and put this all the way down on that side and keep it away. Keep it far, far away. Yeah. All right, so now let's do the negative side. The negative side is over here. That side is not as important. You don't have to worry about it. I should take this apart just so that I could put this cover back on. Wow. Can't find the end of this. Oh, there it is. There you go, that's what it looks like. Let's cover this up, just like that. Let's cover that up nice and neat so it doesn't, there's no chance of it freaking getting shorted out. Just like that. Yeah, I'll put a link to the Amazon rubber cover that I purchased right here. This is a larger one than the stock one, so that way I can cover that up once I put all this stuff on top of that. So all right, so now it's nice and secure and nice and covered. So now let's go over to the other side of this plastic barrier and remove that nut. This side you don't have to be as careful because all this stuff is connected to the body of the car. Just like that. Loosen that up. Pay attention to how tight that nut is. I'm not sure what the torque spec is on that. Pay attention to how tight it was because you don't want to over tighten the nut when you put it back in. All right, so that's what it looks like. It's a nut that has a washer built into it. All right, so now you take this and you pull this out. Just like that. See? I have this negative zip tied to this right here. That way, if anybody yanks on this, it's not going to yank on my my DC to DC converter or my studs over here, and you know, no issues with that. So let's put this nut back on. It's as simple as that. I found out about this Penthouse, this DC to DC converter from a YouTube video I was watching when there is an aftermarket subwoofer that you can purchase for a Tesla Model Y. And that subwoofer is connected to this DC to DC converter. I was thinking about putting a subwoofer, but you know what? The stock subwoofer in this thing, it sounds really good, so I didn't want to upgrade my my subwoofer just because I'm gonna have to lose one of my my storage spaces in the back. So, but anyways, this is back together. Let's make sure it's tight. Yeah, that's pretty tight. And so there should be no more issues. So if you follow these wires, this is your DC to DC converter. It goes along the side of your car here over towards the front, and you're going to see that it's hooked up to to your 12-volt battery in your front, and that's how it charges your 12-volt battery. That's how it keeps on topping it off, and that way your 12-volt battery doesn't it won't drain as long as your car's awake and on. So I'm not sure what happens when your car goes to sleep. I don't know if it monitors it and if it goes, if the voltage gets low, then does it, I don't know if it wakes up and then it continues to top it off or not. I'm still not 100% sure about that. I need to do some research on that. But mine's always on because I always have Sentry mode on, no matter what. I like to have the security around my car all the time, 24/7. So basically, that's it. I'm gonna pull this out and bring it to my house. That way, I can take measurements and show you how I constructed it. That way. So you know what? I'm gonna pull it out this way. I'm gonna take this off. Looks like it's a little bit tight down there. There you go. Perfect. There you go. See? I think that's a pretty nice and easy way to add your power inverter. So now let's put all this back together. Alright. Right here again. Let's line that up with the rib. Just like that. There you go, nice and stable. Let's pop this one back in. Make sure that you line up these two guys right here with that hole, those couple holes. And this is important. This needs to line up with that hole. And this fastener actually broke on my car already, so you can see that this is gone. It's stuck inside the hole. So, but anyways, what's important is that you line this up right here, this stud right there. And then, all right. I think this tab goes inside there. I believe there, just like that. And look on the inside, make sure that this lines up with the slot. There you go. I just lined that up. It's inside. This right here, you can see where that hole is. You got to line that up with that stud that sticks out. Boom. I lined it up. Perfect. And then over here, check this out over here. Make sure, oh, I can see it right here. Your two studs right there have to line up with the hole in the slot. And over here, you can see that these two fasteners are gonna line up with the hole with the two slots, and then boom, you just snap everything in place. Boom. That snapped in, I felt it. The one in the back, I heard that snap. And over here, that's okay, because you lined up that one stud right there inside the hole. That's pretty much it. And then you take this rubber seal and you put this back in place. Just like that. Yeah, perfect. So now it looks back, it's back to stock. Really. Let's put this back in place. Take this and put this inside the hook, the wire harness. And take this, put this inside the hook. And then you want to put this back in here. Oh, it's supposed to go above this metal bar right here. So put it above it, push it in place. Once you push it in place, make sure you pull these seat belt sockets out. That's 1, 2, and 3. There you go. And you slide it in place, just like that. And then you push down. Boom. Push down. Boom. All right. So now everything's back to stock. How do you like that? See? So here we go. I'm gonna go over the construction of my cables and the inline fuse that I used for my setup. All right, let's start from the inverter. This is an Eastwood, made by Eastwood is the manufacturer of this inverter. It's a nice size for me. It's rectangular. Let's see here. The length of it is about 10.5 inches. Actually, there's a base. There's a metal base to this, so it's about 11 3/4 because of this base. 11 and a half. You know, but the top of it is actually only about 10 and a half. About 10 and a half. But then you also got these metal nuts right here that are sticking out. But that's about an estimate of the length. The width is about 5.5 inches, and then the height is about 2 7/8 inches high. So I don't know. I like it. It's a nice size, small enough to fit underneath the sub trunk right there. This is a 1,000-watt pure sine wave power inverter. I suggest that you get a pure sine wave, so it's a nice clean 120 volts going into your electronics. This one has a 2,000 watt max, yeah, that's it. I think it's pretty good inverter so far. It has 2 outlets for your 120 volts. It has a USB if you want to plug in a USB for 5 volts. It has a power button right here that you press to turn on and off. And it also comes with a remote. If you want to plug in a remote control, it comes with that. And then you can turn it off and on from another spot in your car. On the other side, this is where you hook up your positive cable to it. And your negative is down here. So that's how you hook it up there. There's a fan right here to keep it nice and cool. Yeah, so let's take a measurement. So the measurement for the length, I've already measured it. It's about 85 inches long, or about 7 feet long. 7 feet long is about 84 inches. I think I cut it to about 85 inches. The cable. This is a 2 gauge, so you want to make sure you get at least a 2 gauge. So you can see right here, it's a number 2 gauge. Yeah, so you want to get at least a 2 gauge. So far, the cable hasn't been getting hot on me. Even with the length that I have it at. But this is a 2 gauge. And let's start with this side right here. On this side, you're gonna have to crimp. You're gonna have to crimp on a connector just like this. So get a copper connector. This is, let's see, 5/16 in diameter, I believe. So the hole is at 5/16. So this is a 5/16 hole. It's perfect for this, I guess. Well, let me double check that. Yeah, it is perfect for that. 5/16. And this size is perfect for a 2 gauge. So you have to make sure you purchase a copper fitting, electrical fitting that is a 5/16 inch hole and good for a 2 gauge cable. So how you're gonna do that? You wanna strip off some of the insulation there, and then what you do is you install it inside of the copper conductor right here. Insert this inside there, and then you're gonna have to purchase one of these crimping tools. So I bought this one in Amazon. Basically, you insert your cable inside of this, and then you take this, lift it, and then put this inside of your crimping tool. Just like that. Once you got that with your cable inside of it, then you're gonna want to pound on it with a hammer. So do this, and then you're just gonna take a hammer and go whack, 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 until you crimp down on this copper connector. Once you pound down on that, it should give you a nice crimp and a nice connection. And so then you either go ahead and add some solder. You're gonna have to heat this up with the heat with a torch, like a propane torch, which is what I did, but you don't have to do that. As long as you cover it with some heat shrink tubing, you should be fine. So just take some heat shrink tubing, put that around your connection, just like that, and then take a heat gun and heat that up. And that should, as long as you use a heat shrink tubing that has adhesive in it, it should seal and protect it from the elements and protect it from corrosion. So you could see on the inside here the glue actually oozing out. So yeah, I suggest a heat shrink tubing with adhesive. That way it seals all the crevices and cracks and doesn't allow any moisture to get inside and corrode your connection. And yeah, you don't have to solder it. I did, but a lot of people say that crimping is fine, and you'll have a good connection with the crimp as long as you pound on this as hard as you can. And you got it. What's most important, if you're just crimping and you're not soldering, is you seal it with a heat shrink tubing that has glue on it. That way it seals it and makes it waterproof. But yeah, I looked it up online on YouTube how to solder, and yeah, you would just it's pretty easy, but you have to take a torch, a propane torch, and heat this copper up right here. And then once you're heating it, then you would feed your solder inside there. But yeah, it's unnecessary as long as you cover it all up with some heat shrink tubing, and you have a nice crimper just like this tool right here. You don't want to just hammer on this with a hammer. It's just going to make it flat, you know. So eventually that could pull out. Whereas this one, it actually has teeth on the inside here. 4 teeth that actually will bite into the copper, and then that copper will bite into your copper cable. Oh, and make sure you buy all the best materials when you're doing this. All right, you want to lessen the resistance as much as possible. So this is a pure copper cable that I purchased from Amazon. It's pure stranded copper. Do not get the aluminum coated with copper. You don't want that, because that stuff is garbage. You're not gonna get good. It's not as good of a conductor as pure copper stranded wire is. So you want to stick to pure stranded copper wire. All right. I'll put a link in the description so that you can see what stuff I bought. All right, I think that's pretty much it for this side. Let's go over to the Anderson plug. So remember, about 85 inches is how long? About 7 feet, or 85 inches, one inch over 7 feet. I think 7 feet is about 84 inches. So now let's talk about our Anderson plug. So in Amazon, there's a bunch of Anderson plugs that are knockoffs. I didn't want to buy a knockoff. I wanted to buy the real thing, because then I know for sure I have good metal and the best contact and the least resistance. So this is an actual Anderson plug. And right there it says Anderson Power Products. So basically these two pieces fit together, and then they just click in place, and it's like a very, very good connector. Good for the best connector that you can get for these large cables that we have here. So this is what it's going to come with. You need at least four of these, right? This is going to pop into here, and it's going to lock in place, right? So this is what it's going to look like after you crimp it. So again, take your hammer, take your cable, strip your cable as much as you want right here. I don't know how long that is, but I did strip it about maybe 1 inch, about 1 inch long. And then I stuck that inside, and then you take this crimping tool, and then you pull up on it, and then you feed it. Again, you feed it inside like that. And then what you're going to want to do is you're going to pound on this with a hammer. Bam, bam, bam. And so it's going to hold on to your copper wire on the inside of it. And then after you're done with that, get some heat shrink tubing, right? The black stuff. And then same thing. Put that on there, heat it up with the heat gun, and allow that adhesive to ooze out here on both sides and seal that connection. Yeah, I understand what they're saying about crimping, and crimping is okay. You don't need to do soldering. As long as you crimp it really good and you know you're doing a good job with your crimp, you have the right crimping tool, that's never going to pop out, as long as you have the right crimping tool. And then as long as you seal it, again, you got to seal it with an adhesive heat shrink. All right, I think that's pretty much it. Now this, all you do is, once you crimp these on the ends of these cables, and once you put your heat shrink tubing, all you have to do is pop it in place in your Anderson plug. So this is labeled plus and minus. So here's your plus, here's your minus. All you do is you take your red one and you plug it into the plus side, and you're going to hear a click once it clicks in place. Yeah, so this goes into your positive. It's gonna come in here like that. Boom. Once you hear that click, it's in there for good. It's not popping out unless you use a little small screwdriver to release it. Same thing with this one. Make sure you go put it in on the minus side, black for minus. So you got to push this inside. I don't know if you can see that metal spring right there. And then once you push it all the way through, you're gonna hear a click. Just like that. Once it's in there, it's not going anywhere. So that's it. Your minus side, black, plus side, red. And you're golden. All right, so now let's look at the rest of the wiring here. So this, of course, is your other Anderson plug. You're gonna need 2 of these. These are unisex. There's no male, there's no female. All right, they both look exactly the same, right? They both look exactly the same. So there is no male or female on these things. So as long as you buy 2 of these gray ones, make sure it is a gray Anderson plug. They come in other colors, red and other ones, but you don't want that. You want to get the gray one. The gray one is the right one. All right, and get the real stuff, Anderson. Don't get those knockoff brands that they have, because when it comes to electrical, always use the best stuff. You don't want to introduce any resistance to your electrical connections. All right, so from here, same thing on this one, right? I just pulled these out right now so you could see what it looks like on the inside of my Anderson plug, right? So start from here. Let's measure the black wire. This black wire is going to be shorter than the red wire because the red wire's got to come around over to the other stud, right? And it has a longer path that it has to go through to get to the positive stud on the DC to DC converter. So first let's measure the black wire. So the black wire from there to about there is about 26 inches, right? So you got 2 feet and 2 inches, or 26 inches. So that's how long my black wire is. That's how long you should make yours, all right? And let's see what I did over here. Is this the same length? Oh yeah, it looks like it's about the same. So if you want to call this 26 inches, you could do that too, right? Yep, 26 inches. So you're gonna have to cut two pieces that's about 2 feet long, about 26 inches, right? So where were we at? About 7 feet there, a little bit over 7 feet, and then a little bit over 2 feet. That's about 9 feet right there, right? So you're gonna need at least 9 feet. That's why I purchased a 10-foot long 2-gauge cable. 10 feet long. And then a 10-foot long red and a 10-foot long black should be able to be good enough for this project. All right. So I already taught you how to connect it here. You gotta do the same thing that you did on that side. Use the crimper. Use your heat shrink with the adhesive. Same thing on this side. This is gonna look exactly the same. All right. Take your your copper connector. Same thing, crimp it with your crimping tool, and then add your heat shrink tubing on the outside of that, right? And you're going to be happy with this crimper. If you buy one of these, you know it's not going to pop out just because of what that looks like at the bottom of your crimping tool. You know it's going to have a good bite. That you can pull on that all you want and it's never going to pop out. All right. So I think I've described everything up to this point. Now you got to buy one of these inline fuses. This inline fuse, I think I bought this. It comes with a cover. It's clear. The only thing that holds everything together are these two nuts right here. Once you screw these two nuts on here, it will hold on to your inline fuse. This is a 100 amp inline fuse. Supposed to be good for 1,000 watts. 1,000 watt power inverter. All right, but you never want to run a 1,000 watts continuously on your inverter if it's rated at 1,000 watts. They always say you want to run about 80% of what it's rated for. All right, so I only try to run up to 800 watts on this thing. I try not to run anything over 800 watts because it's just not designed to do that. It's going to trip on you. It's going to have a hard time, and you're going to be pushing it to its limit. So limit whatever you're running to about 800 watts, right? And that actually should be about 80 to 85 amps, right? And so that also will run your inline fuse to about 80% of what it's rated to as. So if this is rated at 100 amps, it's going to be pulling about 80 to 85 amps. So you don't want to go any closer to 100 amps because then you're pushing this inline fuse. All right. So I guess after this, you got this part right here. So this is the piece that is important, because it actually connects to your stud, the bolt, or the positive stud at your DC to DC converter, right? So if you look at here's one that I made. If you look at this is what it's going to look like inside of your heat shrink tubing, right? Let's see. Let's measure this length. And of course, the most important part of this whole wiring design that I put together is this piece right here, this inline fuse, and this small little cable here with the two 5/16 inch holes. You want to keep this area as small as possible, because everything from here, where your inline fuse is, and down is going to be protected by this fuse. Right? This fuse is gonna blow, right? Or break if anything happens down the line. If there's a short circuit, if anything positive accidentally touches your negative somehow down the line, or your amp goes bad and it shorts out itself, then this is your protection. This 100 amp fuse, it's gonna blow, and it's gonna cut that circuit off, and nothing's gonna burn down your car. So this is what's important, right? And so you want to keep this cable as small as possible, because from here to here, it's connected to your positive stud at your 12 volt DC to DC converter. So this is not protected from here from here to here is not protected. All right. So you want to keep this as short as possible because you just want to be safe, right? That's the rule of thumb. Keep this as short as possible. So if you measure this, it probably measures out to about 3 inches, right? So you got from here, I crimped it there, 1 3/4, and then from here to here, 1 1/2, right? So that's almost about 3 inches. It's like 3 inches and a quarter, 3 1/4 inches actually, if you want to be technical about it. So that's about 2, and then plus here about 3 1/2. Yeah, this one's measuring about 3 1/2. So 3 1/2, just like that. And you should know how to construct this because I've already explained that to you. Boom. This is what it's going to look like when you crimp it. See the 4 squares right there? Yeah, those 4 squares comes from this crimping tool. So you got that pounding. You're pounding down on this connector and holding on to your copper wire. And you know what happens is if you do solder it, it's gonna wick into here and it's gonna wick into the cable as well. And then it makes this thing not very flexible. That's the only problem when you do solder it. But again, I've done a little bit of research, and I found out that it's unnecessary to do the soldering as long as you do a good job on your crimping and you seal it with a nice adhesive lined heat shrink. All right, sorry for repeating myself so many times, but all right. So I give you the dimension of this cable, and so now I think we're done. Yeah, so I don't know if you want to see what I did here. I held on to this with a clamp, one of my table clamps or vice clamps, and then what I did was I fed my copper wire. Oh, actually, I crimped it first, so now I have a mechanical hold, and then what I did was I held it on my bench vise, and then I heat this up with propane just like this. And then as it's heating up, then I took my solder, and you got to use good electrical solder. Don't use solder that's used for plumbing. You got to use the right solder for electrical connections. All right. Then what you do is you just feed it in there while this is heating up. You feed it in there, and you're going to see it getting sucked in. But it's also going to get sucked in this way. And so that's why this cable is so hard. It doesn't want to flex on me. Right? Yeah, but yeah, that's how you do it if you wanted to do a solder job, but you don't have to. You could just use the heat shrink to seal it. It's much easier. So, all right, I hope that helps you with building your cable for your inverter. And again, you do this at your own risk. You should know what you're doing if you're doing this kind of stuff, and you're willing to take the risk as far as hooking these type of gadgets to your Tesla. I know our Teslas are very expensive cars, and you know, Elon said it's not a car, it's a toy. So I mean, you know, it's built for maximum fun is what I'm quoting what he said. So I have fun with my cars. I mean, why am I going to stop myself from making modifications that's going to make my car better than it already is from the factory, right? So now I have a power inverter that's removable. I can take it out, I can put it back in, very easily. If this video helps you, if you're if it helps you with your build, if you're enjoying my content, please do me a favor. Like this video, give it a thumbs up, subscribe. I have more videos that I'm gonna post on my car modifications playlist. So go to my channel and go to my car modifications playlist, and I'm gonna place all of my mods that I do to the to my car in there, so that you can reference it just in case you want to do it to your car. All right, I think that's pretty much it. You can go 0 gauge if you want. That's actually the best cable to use, but the larger the gauge, the harder, the heavier all this stuff becomes, because this cable is heavy enough, you know. And if you go with a 0 gauge, it's going to be super heavy, and it's harder to, you know, take in and out of your car if you wanted to, or it's not as flexible as well, right? So that's why I went with a 2 gauge, and I'm not pulling 100 amps either. You know, I'm keeping it to 800 or 80 amps, about 85 amps, and at 800 watts. And I don't know, I was feeling the cable. It didn't feel hot at all, so it wasn't heating up at all. So I feel like as long as you're using the best stuff, pure copper cable, stranded, you shouldn't be introducing any resistance. But if you use that stupid aluminum cable that's coated with copper or whatever, that cheap stuff, forget it. You know, your cables are gonna heat up, and it's just not a good situation for your car. You don't want your car burning down. Oh yeah, one more thing. This kind of stuff voids your warranty for sure. All right, because it's all over the internet. You know, there's some fine print in the Tesla manual that they do not suggest using the Tesla as a stationary power supply. Do not use your Tesla as a stationary power supply. That's what it says in the manual. But from what I've listened, what I've watched on YouTube and stuff like that, it's I've seen other people use it for about 1,000 watts,